Okay, so this is for test 3 video for extra credit. The first one I'm going to do is the coffee cup calorimeter with limited reagents. So I picked problem number 4 on the test 3 practice. A well-insulated coffee cup calorimeter is used to measure the heat involved when the following aqueous solution, both initially at 22.60 degrees Celsius, are mixed, containing 6.62 grams of PbNO32, the molar weight of 331.2 grams over mole, 6.00 grams of NaL with the molar weight of 149.89 grams over moles to form a 200 milliliters aqueous solution, whose density is 1.0 grams over milliliters. The final temperature of the solution is 24.20 degrees Celsius. Assume the specific heat of the solution is 4.184 joules over grams times degrees Celsius. Calculate the delta H. Okay, so that's the question. So as you can see here, make sure you can see me. I have PbNO3 aqueous solution plus 2 NaL aqueous is arrow PbL2 solid is plus 2 NaNO3. So we first use the equation Q solution is equal to M solution times C times delta T. To find M solution, we need to take density times volume, which I did here. M solution, which in the problem it gave us 1.10 gram and 200 milliliters, which gave me 220 grams. Then to do C, which is specific heat, I took 4.184, which is given in the problem, joules over grams degrees Celsius. You divide it by 1,000 to convert that to kilojoules over mole of Rxn, which is 0.004184. Then to do delta T, that's temperature of final minus temperature of initial, which is 24.20 degrees Celsius minus 22.60 degrees Celsius, which gave me 1.60 degrees Celsius. So now I can plug in my M solution, my C, and my delta T into my Q solution, which after you plug all that in was 1.47 kilojoules. So now I need to find my limiting reactant for PbNO3 and NaL. So they gave me the grams in my question of 6.62 grams over 1 times 1 mole of PbNO32 over the molar weight of 331.2 grams, which gave me 0.02 moles of PbNO32. So I do the same process with NaL, and that's as given in the problem, 6.00 grams over 1 times 1 mole of NaL over the molar weight, which gave me 0.04 moles of NaL. So now that I have those two, I can go to PbNO2 and I can find the limiting reagent. So you divide that by over 1 and you times it by 2 moles of NaNO3, which that's when you do the ratio over 1 mole of PbNO32, because remember you're trying to cancel out, and that gave me 0.04 moles of NaNO3. Now we do it for the second one of 0.04, which we got from here, over 1 times mole to mole ratio, which gave me 0.04 moles of NaL. So we notice that 0.04 is the same as 0.04, so there's no limiting reagent in this question. Moving on, so now we use the equation delta H is equal to Q over mole. Delta H, remember we got for Q solution is 1.47 kilojoules over the 0.04 moles of NaNO3. I just went ahead and picked one since there's not a limited reagent, we can just choose, which gave me 36.75 kilojoules over mole of NaNO3. Now we have to convert. So I took that answer over 1 times the ratio, 2 moles of NaNO3 over 1 mole of RXN, which gave me 77.5 kilojoules over mole RXN. Because now we need to determine if this is a negative or positive. Because delta H is negative if T final is greater. Our T final is greater, going back to the T final of 24.20, that's our T final, meaning that this is negative 77.5 kilojoules over RXN. And that concludes problem number 4. Don't hit. Now we're going to go on to a stoichiometry using thermochemistry problem, which should be somewhere here. I think it's number 3. Yeah, number 3. So going to number 3 on the practice form thingamabob. The thermite reaction using for welding iron, the reaction of Fe3O4 with Al. Calculate the delta H degree F of Fe3O4. So it gave us the equation, it gave us delta H is equal to negative 3350 kilojoules. Because this large amount of heat cannot be rapidly displaced to the surrounding, the reactant mass may reach a temperature of 3000 degrees Celsius. How much heat is lost by the reaction of 27.6 grams of Al with 69.12 grams of Fe3O4? So we first set up the equation. Oh, my bad. I pointed at the wrong one. So we use delta H is equal to Q over mole again. And it gave us the 27.6 grams of Al. Then you want to use the MW. I'm blanking. The molar weight to find your moles of 1.02 moles of Al. Then you're going to use the ratio. Remember, you're picking from the product side. So we picked the Al2O3, and we put that with a ratio of 4 moles of Al2O3 over 8 moles of Al, because remember you want to cancel out your Als. And that gave you 0.51 moles of Al2O3. Now you do the same thing with the 69 that was given, 69.12 grams of Fe3O4. And you divide it by the molarity weight, the mole. And then that gives you 0.229 moles of Fe3O4. Then you want to do the ratio of 4 moles of Al2O3 divided by 3 moles, because remember, canceling out the Fe3O4, because you want Al2O3, because that is what you are looking for as far as your moles. Now, 0.40 mole is less than 0.51 mole, so we know our limiting reagent is Fe3O4, which is what we're trying to find. Next, you're going to set 3350 kilojoule, which is in our problem, over 1 mole of RXN, times, remember our ratio again, of 1 mole RXN divided by 3 moles of Fe3O4, which is given in our problem, times, remember, since this is our limiting reactant, we will use the 0.299 mole of Fe3O4, and that gave us 334 kilojoules over mole of Fe3O4. And that will conclude problem number 3. I still got one more.
Okay.
And then so we have another one using Hess's law, and that one will be number 6 on the practice test. And so it says, calculate the delta H for the following reactants of NO2 grams. It gave us the equation, and it gave us delta H degree final of NO grams is 90.25 kilojoules over mole, and delta H degree final is NO2 grams, for NO2 grams is 33.18 kilojoules over mole. So for number 6, I wrote out the problem. And then we use this equation, which is Hess's law, to divide the products and the reactants. because to find delta H degree of Rxn, you have to do the sum of N times delta HF degree of products, which remember our products is on this side, the 2NHNO2, minus the sum of M times delta H degree F of reactants on this side. So I separated it out into products and reactants, wrote out the formula first. So you're going to do 2 times, because you have a coefficient, 2, times delta HF degree of NO2 from the equation. So 2 times 33.18, which was given here, gave me 66.36 kilojoules over moles. So you do the same thing on the reactants. I separated the equation. 2 times 90, which was given, 90.25 kilojoules over mole. Same thing for oxygen. Remember, you can find this on the periodic table. 66.36 kilojoules over mole minus 180.5 kilojoule over mole gave you negative 114.14 kilojoules over mole, which concludes the delta H degree of Rxn for problem number 6. Thank you.
You're done?
Mm-hmm.
Okay.